All right, so here's help with the practice part. So this is your practice, like the exact same problems as your practice problems that we're doing in class today for the classwork, okay? So I'm gonna twist this a little bit more because I write a little bit slanted. Hold on. Okay. So this is how we put this into practice. I told you to remember the main thing was that formula. Okay, so I'm gonna write down, and I'm gonna abbreviate average atomic mass. I'm gonna abbreviate it as AAM, okay? So average atomic mass equals mass A times percent abundance of that one, of that specific isotope, plus mass B times percent abundance of the second isotope, plus ... Okay, you do that over and over for each isotope given. Here, how many am I given? I'm given, calculate the atomic mass, average atomic mass for neon if its abundance in nature is 90.5% neon for neon 20. I'm given neon 21 and I'm given neon 22. So I'm dealing with 3 isotopes. So I'm gonna have to do this process 3 times, okay? So the first thing I'm gonna do, guys, is just write out the information. So I'm given 90.5% for neon 20. So neon 20 is, and I'm gonna go ahead and do different colors here, 90.5%. And then neon 21 is 0.3%. And then we have neon 22, because again, these are different isotopes of the same element. Different color, 9.2%, okay? So your first step, and if you wanna like write this down to remind yourself that, is to convert, and I'm gonna write it on the side here, is to convert your percentages to decimals. Okay, so that's what I'm gonna do. How do you do that? Literally move the decimal over to the left 2 times, okay? And if you don't understand why, go back to percentages. What is a percent? The root cent is 100. How many zeros are there in 100? 2. So whenever I'm trying to convert a percent, say I have 10%, I wanna convert that to a decimal, I'm gonna, even if I don't see that decimal there, that's where the decimal is sitting for this percentage. And since there's 2 zeros in a 100, I'm gonna move it over to the left twice, okay? Even if you don't understand that, that's the rule, guys, okay? So take this decimal for 90.5, I'm gonna move it over to the left twice to get 0.905, okay? And then same for 0.3, I'm gonna move that decimal over to the left twice. So then I get 0.003, okay? And then same for this one, over to the left twice. So then I get 0.092, okay? So that's your first step, done. Next step is, I'll write it down here, plug it into your formula. And just make sure they each line up with each other. So neon 20, I need a mass for that. I'm not given a mass, but wait, what does this number stand for again? The mass number. So for my first substance, it's gonna be, and let me use a different color for this. So my average atomic mass would equal my mass A, 20, times the percent abundance in decimal form, 0.905, plus second mass, 21, times the percent abundance in decimal form, 0.003, plus neon 22, 22 times 0.092 equals, okay? Next thing, guys, plug it all into a calculator. So, average atomic mass, and yes, I keep rewriting this so that I can keep organized. So I have 20 times 0.905, I get 18.1. And also, please make sure not to round until the very end. Keep all the decimal points. 21 times 0.003, 0.063 plus 22 times 0.092. 2.024. Then I'm going to add those three numbers together exactly the way I see them. 2.024 plus 0.063 plus 18.1. And I get 20.187. The units for this would be AMU, atomic mass units, okay? If we're trying to find the average atomic mass. Let's make sure that, okay? And that's it. That's your average atomic mass. Okay. That might have seemed like a lot, so if that was a lot for you, pause the video, go back and watch it again, follow along on your own paper. Okay, now let's do a little bit of maybe one that doesn't blatantly give you a percentage, so like this one. So let me go back to number 3 really quick. Again, and if you have questions on the homework, feel free to email me, and I can meet with you for tutorials if this doesn't make sense. Totally willing to do that. However, this one, you're doing this exact same thing, but it says calculate the average atomic mass of element X. Then use the periodic table to identify the element. How would I do that? If I have the atomic mass, I should be able to identify the element as well. Okay? So, and we'll get to that in a second. So here, you're still following the same formula that we did up here, but you're given the mass here. You're not using this one. You're using the more accurate one, the more precise one. And you're doing this times this in decimal form, this times this in decimal form, and then plus this times this in decimal form. Okay, hopefully that helps because I know charts confuse people. And if it doesn't, see me in tutorials. Now, what about this one? Number 4, I'm not given a blatant, percentage, am I? However, a fraction, how do I convert that into a percentage, or more so into a decimal? So this is actually easier. So calculate first, let me go back. How many isotopes am I dealing with here? I'm dealing with silver 107 and I'm dealing with silver 109, right? So I'm gonna write that down. Silver 107, silver 109. Okay, so it says calculate the average atomic mass of silver if 13 out of 25 is what I'm given atoms are silver 107 and 12 out of 25 atoms are silver 109. Guys, fractions are decimals, and if you don't remember that, plug in 13 divided by 25, 13 out of 25, what do you get? 0.52, a decimal. So automatically, we kind of just skipped a step. We don't even need to convert it into a percentage. I already have my decimal. Because if I were to move the decimal over twice to the right, that would be my percentage. This would be 52%. Okay? Now, 12 divided by 25, 0.48. So you're using these as your decimal numbers for this one. But it's the same process. And I want you to do it. I'm not going to do the whole thing for you because there's only 5 problems on this. Okay? So hopefully that's a little helpful. If you're still confused, feel free to come see me in tutorials. Okay? All right, y'all.